Hello everyone, my name is Arohi and welcome to my channel. So guys, in my today's video I'll show you how to create a chatbot which can answer questions based on your dataset. So for this task we are going to use RAG, and guys, if you don't know what RAG is and what is the need of RAG, how to use RAG, then you can check this video. In this video I have explained in detail that what is RAG and how to use it. In my today's tutorial we are directly starting with the coding part, and today we will use RAG, and with the help of RAG we will provide external knowledge to the LLM, and the LLM which we are going to use for this tutorial is Gemini. Gemini is a LLM by Google. So using RAG will provide external knowledge to the LLM, and then this LLM will answer the questions based on our dataset. So let's start. The first step is to create the environment, and for that you will open an Anaconda prompt and then writing this line, this command conda create -n and then the environment name in Python 3.10. This means we want to create the environment with Python 3.10 and then hit enter. You will have the environment created. After that you need to activate the environment, and for that you will write conda activate and then the environment name. Environment name is this. Our environment is activated now. After that we have to install all the required packages which are needed for this tutorial. So for that I have created our requirements.txt file. So guys, this is the requirement.txt file. Let me open this file. Okay, so these are the requirements we need for this tutorial. And this requirement.txt file is present in this folder, lecture 8 RAG demo Gemini. So I have provided the link of this code in description section. You can get this code from there. We have to enter in this folder in order to install the requirements from here. So for that we are doing p drive, and then I have this folder. So this is the folder where my requirements.txt file is. Now I will install all the requirements by writing this. Okay, and then hit enter. After that you will have all the requirements installed in your environment. Now we are ready to run the code. So guys, before creating an app, I want to show you the basic concepts of the RAG which we are going to use, and then using all those concepts we'll create an app. So let me open a Jupyter notebook to explain you all those concepts. So to open a Jupyter notebook you will write Jupyter notebook and hit enter. So this is the Jupyter notebook, and here let me click this. Here we are going to write a code. First thing is the data on which we want our LLM to answer our queries, right? So for my today's tutorial I'm using this PDF file. We will provide, this is a YOLO V9 paper, and here you can get it. This is the external data which we are providing to our LLM, and with the help of RAG our LLM will answer the questions based on this data, this PDF file. Alright, so using this PyPDF loader we can load the PDF files, and this PDF file I have placed in my folder over here. See, so this is the Jupyter notebook I'm showing you, and this is the PDF file, and using this .load you can load the file, and after that if you print this data variable you can see the data. See document, and here you can see the data of the paper. So guys, now let's move to the next step and let's try to check the length of this data. So here you can see 18. What does this 18 means? This 18 simply means that our PDF file have 18 different pages, and for each page we have a separate document. See this document, first document you will see till here. See, this is the data which is present on first page of the paper. Then we have a second document which is starting from here, right? And here you can see the data of second page till here. Then we have a document number 3. So like this we are having 18 documents because this paper have 18 different pages. So if you scroll down, you can see the different pages, page number 4, 5, okay, like this you can see. So this we have here. Now the next step is to split this data into smaller chunks so that when user will ask a query, so we will pick only that text chunk, we will pick only that portion of text which is related to the question which user asked. So for that we will use this recursive character text splitter. Using this, we will split the data which is present in these 18 pages. We'll split that data into smaller chunk, and the size of each chunk will be 1000, and you can change this number. And then using this split document, we are splitting the data which is present in the data variable. And after that, I'm checking the length of the documents. Now let's see how many documents we have. See, earlier we were having 18 documents because there are 18 pages in that paper. But after dividing, after splitting that those 18 documents, we are now getting 96 separate small documents. Okay, and the reason to create these small documents is simple, that we only want to pick the data which is related to the question which user asked to the chatbot. So that's why we divided the data into smaller portions. Now let's try to see one of the document. Let's see the document which is at this index. See, document which is at third number index, this is the data in that. In the same way, you can check the document which is present at 7th number. So this is the document. See, we are having smaller documents now, and there are 96 documents. So the next step is to convert the text into numerical representations. That means we will perform embedding, and with the help of embedding, we want to convert this, all the documents, the text which is there in all the document, we want to convert the text into numbers, numerical representations, and for that we will use the text embedding model, and this is the code for it. So here we are using Google generative AI embeddings. So guys, there are various embedding models, and if you want to see what are the options we have to use for the embedding models, then you can open this link. Here you can see we have different embedding models, right? Here you can see these are the different options. So for my today's tutorial, the model which I am using is I'm using the Google's embedding model, this one. And in my previous video, I have shown you how to use the OpenAI embedding model. Okay, so today we are using Google's generative AI embeddings. Embedding will convert the text into numbers, and then we are importing this Chroma. Chroma is a vector database, and vector databases are used to store the embeddings. The embeddings which we are going to create using this embedding model, those embeddings, those numbers, those numerical representations we are going to store in Chroma database, because Chroma database is a vector database, and here we can store the embeddings. Now guys, if you want to use the Google's generative AI embedding model, and in my today's class I have told you that we are going to use the LLM, Gemini LLM, and Gemini LLM, if you want to use, for that you need a API key from Google. So to get the API key, you can just copy this link from here and just paste it here and hit enter. So guys, to get this, first you will see this kind of page only if you are logged in. So you first need to log into your Google's account. After that you will see this get an API over here. So just click on this get an API key, and you just need to follow the further process, and like this over here. So in my case, I already have a API key over here, so I am not generating a new one. So in your case, you will click on this and you will get a API key, and you will copy that API key, save that API key somewhere. So once you get the API key from here, you need to paste that API key, okay, in this .env file. So guys, this .env file, let's open it. So here it is. So here see Google API key, and here you will write the API key which you have. This key will not work in your case, so you just need to have your API key and paste that API key over here, and then save this file. Now here we are using the Google's embedding model, and this is how you can call it. So from this I want to use this model, and just in order to test it whether we have loaded the embedding model properly or not, so we are just trying to embed this. So we are just trying to convert this into numbers, and then I'm printing the vector, and you will see some sort of numbers over here. So those are the numerical representations, right? So these kind of numbers we are going to create, and those numbers we are going to store in the Chroma database. So we will not understand the meaning of these numbers, but these numbers simply means for each word there is a number. Okay, there will be a unique number for each unique word. And now we know that the embedding model is working properly. Now we will apply this embedding model on the documents, all the documents. How many documents we have? 96. So on all these documents we will apply this embedding model, and we will convert them into numbers, and then we will store them into Chroma database. Now let's perform that functionality. So using this single line, using this single line Chroma from documents, first we are providing all our documents over here. We have our documents in docs, right? Here we have splitted the data. So first we are providing all the documents, then we are applying the this embedding model on it, and once we get the embedding, we are storing those embeddings in Chroma database, and we have all this work done in the vector store variable. So let's execute this. Now the next step is, here we are using this vector store as a retriever. So guys, again I'm telling you, if you don't know what is retriever, so check my previous video where I've explained all these things in detail. For now, just understand that retriever simply will fetch the document which are related to the question which user asked. So this is the question which user asked. So from out of these all 96 documents, what documents are most matched with the user query, we will get those documents with the help of retriever. And here we are just trying to use our vector store, this vector store, as a retriever. Okay, so guys, we can use any vector database as a retriever. So in our case, we are using our Chroma database as a retriever, and search k value 10 simply means we will fetch out the 10 documents out of these 96 documents which matches the user query the most. And let's hit it, and let's see, we executed this code, and let's try to print this retrieved document. You will see the 10 different documents over here. So okay, here you will not understand. Let's try to check the length of this retrieved document. The length should be 10, because what we have written is that we need the 10 most matching documents as per the user's query. So we have the 10 documents. Now let's try to see the content which is present in these retrieved 10 documents which retriever provided us. So for that, you can write this here. What I'm writing is retrieve document. I want to retrieve, this is just to display, this is just to show you that what kind of documents we got. So what I'm writing here is that from retrieve documents, get the document number 5 and print the page content. So this is what we have in the document number 5 document, which is present at index number 5, right? So this is how you can see the data. Now we will write the code to call the model. So this is the model we want to use, Gemini 1.5 Pro model, and to use this model you need to import this module from the Langchain Google Gen AI. Temperature 0 means output would be more focused, and if the temperature is 1 or the values which are closer to 1, that means your model will be more diverse. It will provide you the answers randomly, right? 0 means more focused, and if you'll write 0.2 2 or 3. You can write any value between 0 to 1. If you are looking for more focused output, then try to make this value closer to 0. So in my case, I have written 0.3. Max tokens means the number of words you want in the output. So let's say if you set it to 500, this means your model response will not be more than 500 words. Okay, so let's set it to 500 for now. And we have our LLM in this LLM variable. Now this is the next step. Here we will create a chain, we will write a prompt. Okay, and first we are importing this and this. Why we need this? Let's understand that. So guys, in this variable we are creating a system prompt. System prompt means we are creating this prompt for our LLM, and here we have written a placeholder context. What will be the data over here in this context placeholder? The retrieved documents. What retrieved documents? So over here we have retrieved the 10 documents which matches the user's query the most. We will provide those 10 documents over here, right? So retrieved document will be placed over here, and then this will guide your model to generate the output. And then we have a prompt. Here we are creating a prompt template, and for this system, for your chatbot, we are using this prompt, the prompt which we have defined over here. And for human, this input simply means that the question which user will write in a chatbot, the input box which we have in a chatbot, the user will write a question in over there. That data we will be putting in this placeholder. Okay, so this is the prompt. Now let's hit enter. Now let's create a chain to execute this task. So this is our chain. First we are using this function, and the parameters we are providing to this function is LLM and prompt. Prompt is here, and LLM we have defined over here. After that we are creating a chain, and this thing we have already imported over here. Create retrieval chain. And retriever, what is the first parameter? Retriever. And what is there in retriever? The task of the retriever is to fetch those documents which match the user query the most, and we have that retriever defined over here. See, here we have defined that retriever, and we are providing this question answer chain over here, the line which we have defined here. Now our chain is ready. Now let's try to use this chain. We want to invoke this chain input. This is the question from the user, what is new in YOLO V9, and then we are displaying the response, and using this chain we are getting the response. Let's try to see what kind of answer we get. See, YOLO V9 introduces a new architecture called GLAN, and then you can read this. So this is how we can work with RAG, and over here we are using the RAG with Gemini LLM, and our custom data, our own data is present in the PDF file, and this is how we can work with it. So these are the basics. Now you understood these basics, right? Now guys, let's say if you want to work with a website, you have your own website, and you, instead of this, let's say instead of loading the data from the PDF, what you want is, you have your company's website and you want to build a chatbot for your company data, right? So then how we can do that? So for that you will open this basic RAG website, this code. So here we are importing what? This unstructured URL loader. With the help of this we can load the pages of the website, and in this URLs list I'm loading the page of website. So this is the first page, this is the second page of the website, and this is the third page of the website. On the basis of these three pages, I want the chatbot to answer the queries of the user. So we are loading the data by using this module. We are providing all the URLs to it, and then we are loading it like this. And if you want to print the data, you can, okay, first we need to hit enter. See, now you will see the data from the website. Okay, now we have the data. So guys, this is the only change. Apart from that, the code which I have shown you, we will use the same code to perform the functionalities. You can see here we are using a text splitter, because what we want is, we want to the data which we have from these 3 pages, what we want is, we want to split that data into smaller documents, so that when user will ask a question, we will only pick that section, that document, that smaller chunk of text which is related to the question which user asked. So for that we are using this, and we have total number of 15 documents. And here I'm just showing you the first document, right? So after splitting the website pages into smaller documents, so this is one of the document. And then here we are just, once you have the data, we want to convert it into embeddings. So that's what we are doing over here. Rest of the steps are same. So this Jupyter notebook is also provided in the description section. So now you can work with the PDF file also, and you can work with the website also. Now let's try to create an app using the concepts which we have learned now. So this is the code. Now app1.py file. Let's open this file. Here. First, we are importing all the required modules. We are importing Streamlit because we are going to build a web application using Streamlit. And then we are loading the PDF loader, because the data which we want to load, the external data which we want to provide to our LLM is a PDF file. To load the PDF file, we need this loader. Then we are loading the recursive character text splitter, because once we load the PDF file, we will split that file into smaller text chunks, and we are doing that with this. And once we have the data divided into smaller documents, we are converting that data into embeddings, means we are converting the text of those smaller text chunks into numerical representations. And for that we are using this. Those numerical representation, those embeddings, we are storing in a vector store. Which vector store we are using? Chroma. And then we want to use the LLM. Which LLM we are using? Gemini. Gemini is a LLM by Google, so we are loading this module for that. After that, we want to create a chain to work with the LLM. So these are the modules for that, and this is the module which is related to with the help of this you can provide a chat prompt template. Alright, and with these 2 lines we are loading the environment variable which is present in the .env file. And what is there in .env file? Your Google's API key. And with the help of st.title, we can provide the title to our app, and the title to our app is this. Here we are loading the YOLO v9 paper. .load will load the data. We are splitting the data into smaller chunks, and then here we are converting that data into numerical representations, and then we are storing those numerical representations or embeddings in Chroma database. And then we are using that Chroma database as a retriever. That retriever, then we have a large language model. So we are using Gemini 1.5 Pro large language model. And then this line is responsible to get the input from the user. Okay, let me start the app, and then we will understand the rest of the code. So to start the app, let me just close everything. So to start the app, you will first open Anaconda prompt. You will activate the environment, conda activate env_langchain. Environment is activated. Then we will enter in the folder where our code is. So here is my code. Now we have created a Streamlit app. So you will write Streamlit run and then the app1.py. This is the code. So here you will see the app. So we have an app over here, and here is the text box, input box, where user will enter the questions. So let me open the code now. See, st.chat input, here the placeholder is say something. So this is what we are getting here. Okay, and after that, so this is the system prompt, guys. This part I have already explained you in the Jupyter notebook. And then here is our prompt template. System prompt we are getting from here, and when for human we are using this input placeholder. This input placeholder will write the question which user will type over here. Okay, and then if query simply means if user entered a question, then we want to use the chain, this chain, and the result, the answer, the response of the LLM we are getting like this: rag chain dot invoke the input. This is what we are providing to the input query. What is there in the query? Whatever user will type in the input box, it will become the input to the rag chain, and then with the help of st.write we are showing the response on the Streamlit app. Okay, so this is our code. Now let's try to run the application. Now let's ask what is new in YOLO v9. See, YOLO v9 introduced two new components. First is PGI, and then this GLAN, and then this. And now let's ask how PGI work. So here you will get the answer of that. So guys, you can see here that our LLM, Gemini Pro LLM, providing us answers on the data which is present in our data set, right? And how Gemini Pro is able to answer the questions based on our data with the help of RAG. So that's it, guys. I hope this video is helpful, and if you like my video, please like, share and subscribe my channel. Thank you for watching.